Hello, my Algebra 2 scholars. We are working in our Big Ideas book. This is section 4.5, or C4L5. The title of it is Solving Polynomial Equations. So these are some notes and examples that I'm going to give to you, especially if you're home on quarantine. And you should be able to follow along with me, and I'm going to write a few things down. But basically, we've been factoring polynomials. So there's really only one more step, okay? If you know one factor of a polynomial, then what you're going to do is you're going to divide the larger polynomial. You can divide it into the polynomial, and you're going to then further factor that smaller quotient. Okay, and the key word here is further factor until you're able to get down to factors that can no longer be simplified, that are simplified. You can't take out any greatest common factors. You can't apply any special patterns. Nothing like that. So this further factor is going to be the point that's really important. So here's just an example. And we did this in quadratics as well. So say I give you a polynomial called g of x, and it is a cubic. It's x cubed minus 5x squared minus 6x. And I tell you that the binomial x minus 6 is a factor. Okay, so I'm going to set this up. I'm going to divide this into this. Okay, then you'll get a quotient. The easiest way to do this is using synthetic division because I have a single linear factor. And so remember, this is x minus a. So a here is 6, which means that 6 is going to go outside my little box. I'm going to do my upside down box here, and I need to account for every power. So this has a coefficient of 1 for x cubed, negative 5 for x squared, negative 6 for x, and then I'll 0 for a constant. So remember the process that we did last week? I'm going to bring down the 1. That just comes straight down. 6 times 1 goes here. Add these together. 6 times 1 goes here. Add them together. 6 times 0 goes here. And of course this shows, right, this is your remainder, which we knew it would be 0 because it's a factor. And this right here is your x to the 0. This is your x to the 1. This is your x to 2 when you go this way. Remember, when you do x cubed divided by a single x, you're going to end up with an x squared anyway. So these are the coefficients, and now you can rewrite it like this. G of x, my original polynomial, is equal to x minus 6, that's the first factor, times x squared plus x, and there's no constant. And now when I look at this, I think, you know what? I know this is a factor, but can you factor this anymore? Of course you can. You can take out a GCF of x, a greatest common factor. So then, completely factored, it's going to look like this. X minus 6 times x plus 1. And I now have g completely factored. That makes sense. I have 1, 2, 3 factors, and I started with an x cubed, so it looks like I have them all. Now that's what we did in 4.4. Now here's the part. In 4.5, we're now going to solve. So to solve this polynomial, set equal to 0. Remember how we do this in the quadratic formula? So it's 0 equals x minus 6, 0 equals x, and 0 equals x plus 1. That's each one of these factors. So you can solve for that. You would add 6 to both sides here and get x equals 6. This is, of course, x equals 0. And you would subtract 1 from both sides to get x equals negative 1. So these are my zeros, my roots, my solutions, my x-intercept. So you would write at the end here for our notes, the polynomial g of x has zeros or roots. I'm going to write them all out. Or we also call them solutions, and we call them x-intercepts at x equals negative 1, 0, and 6. That's what it means to solve polynomials. We get all the way down to the end. Now there is a slight bit more in 4.5 that I want to review with you as well, so there's a little bit more. If you're following along in your video, in your student journal, for the problems that I want you to do on page, your assignment is going to be your student journal, pages 99 to 100. I'm going to have you, it's 1 through 12. No, it's 1 through 13, I believe it is. But I'm going to have you skip number 11. Okay? And on number 12, I would like you to start with x plus 4 as a factor. Okay, x plus 4. Now, just as an example, if you look at number 12, you're going to divide this into the bigger polynomial just like we did before, and good luck. Let me know how you do that. Now, on page 98 of your student journal, there is one more thing. It's called the Irrational Conjugates Theorem. There's just one more little factoid we need to add here to our notes. Irrational Conjugates Theorem. It's a very simple idea, but again, it's something that you're expected to know, especially if you're going to do standardized tests. So here's an example. Write a polynomial function g, okay, of least degree that has rational coefficients. So we're not talking about any weird functions here. We just want some nice rational numbers. It has a leading coefficient of 1. Okay, and the zeros, negative 5 and 4 plus the root of 2. So whatever that number is, it's a decimal. So here's what it says. The Irrational Conjugates Theorem on page 98 says, if you have a root like this, where it's got an irrational number, then it always comes in a double root of also 4 minus root 2. So this has to be at least a cubic, because you've got 1 root, 2 root, and you can't have a root like this without a third root. And that third root is going to be 4 minus root 2. And that is a conjugate. Okay, so if you have an irrational number like this, it has to have both of them, both the plus and the minus. Which would mean, here's your solution. Okay, so your solution is, this right here will give you x plus 5 as a factor, because it's x minus a. But then this one will give you x minus 4 plus root 2 as a factor, and the Irrational Conjugates Theorem will also give you x plus 4 plus root 2. So what you need is that minus and that plus with the irrational. And that, of course, is equal to g of x. If you multiply it all out, you will get an x cubed function, and you'll get other rational numbers. We're just going to leave it like this for now. The idea is that if you get what the roots are, you can write the function. And if you want to further multiply it out, you can do that as well. For MCR, we're just going to leave it like this, and g of x has 3 roots. So good luck with that. I will keep in touch.